Hello, everybody. Welcome to a lesson on systems of equations, chapter 12, lesson 10. Focus for today, I will solve a system of linear equations by graphing. Now, there are other ways to solve equations. I just want to be clear about that. So eventually, you're going to learn not one, but two other ways, other methods to do so through substitution and elimination. It works really well when graphs don't always give you the best of answers. But for today, our focus is on graphing. So we're going to take everything we know about graphing a linear equation, using the slope, using the y-intercept, with a t-chart, without a t-chart. Most of us are going to prefer without. And we're going to be able now to put not just one, but two lines on a single coordinate plane. Pause, come on back when you're ready. I have a number of examples, ladies and gents. I don't know what you'll be able to do without some graph paper, so we'll see what we go. We'll do this together, huh? All right. First and foremost, let's go ahead and identify which two equations, when graphed, will pass through the point 1, 2. Now, if you wish, you can pause and come on back when you're ready. For the rest of us, let's take a look-see, shall we? Let's look at the first one. I'm going to put a 1 right here, and I'm going to point out the y-intercept of positive 1, so I'm going to put that point on the graph. A slope of 1 to 1, and 1 to 1, and 1 to 1 does seem to identify a certain yeah, it sure does go through it. So, first equation is going to be y equals x plus 1. That one does go through the point 1, 2. And to be clear, I kind of could have realized that by substituting a 1 in for the x value and a 2 in for the y value. 1 plus 1 is clearly 2. Yep, that's true. All right, let's keep going. So negative y equals negative 2x. Since it doesn't have anything there, I'll put a plus 0. Negative 2 to 1, so it goes down 2 and right 1 or up 2 and left 1. Yeah, I don't think so, folks. That will not go through the red point. So we're going to give that a big old eh. Let's try the next one. Y equals x plus 2 being the y-intercept. Slope of 1 to 1 goes up 1 and right 1 and up 1 and right 1 and up 1 and right 1. Now, that's interesting. It actually is parallel to the other line, but it does not go through the point we're looking for, so that gets a big old gee, I wonder what that means. Y equals negative x plus 3 being the y-intercept. I'm going to squeeze a 1 in right here and then put another one, negative 1 to 1. So go down 1 and right 1, down 1 and right 1, down 1 and right 1. And if we were to graph a line through those points, yep, you got it, ladies and gents. Those do appear to be the two lines that both of which will go through that point. Now, I know this might seem silly, but keyword being through, keep that in mind. So, with that, can I just point out, oh, that was a bad math joke, Mr. Cowan. We are looking for the point of intersection, as in the one x value and y value. That would be true for both. See, here's the deal, guys. Even one line has an infinite number of x values and y values. Decimals, fractions, ugly numbers, rational numbers, even irrational numbers. But none of those blue points work on the other line. And I could say the same thing about the other line. Tons of points would be true for this second equation. But we were looking for the point, the one x value, the one y value, that would be true for both. In fact, let me get some different colors here. Let's substitute in 1 for x, 2 for y. 1 plus 1 is 2. Yep, looks like a true statement to me. Let's go with a different color here. 1 for x, 2 for y. Now the opposite of 1, of course, is -1. Sorry about that little blurb. -1 plus 3 is 2. And yeah, that one looks true. So it is true for both. That's why that point is such a big deal. All right, let's go through some real world examples. If I'm going too fast, pause, rewind, do what you got to do. www.moviesyouLike charges $3 to download a movie. We'll call the number of movies X. That's the missing piece, the variable. G8 Movies charges a sign-up fee of $3. You got to pay $3 just to sign up, but then it's $2 per movie, which sounds kind of nice. Our goal is to write an equation for each. So first thing we're going to do is write y equals, although I wouldn't be at all surprised if you guys would prefer cost equals. Now think about movies you like, $3 to download a movie, so it's going to be increasing $3 per X. Is there any sign-up fee or additional charge? I don't see anything. Now, you don't have to write +0 if you don't wish. That's totally up to you. Let's go ahead and take a look at the other filler. G8 Movies, sign-up fee of $3, $2 per... Okay, so wait a second. If I were to write this, you could write start with 3 and then go up $2 per movie. I'm going to write it in y equals mx plus b form, where the $2 per movie is the slope, and then there's the one-time fee. Notice there it's not $3 per movie. So that 3 should not be changed and multiplied times x movies. It's just y equals 2x plus 3. All right, now let's go ahead and plot these both on a coordinate plane and see what it looks like. I'm going to use different colors just to make it a little nice. Let's use red and blue. All right, we got y equals 3x plus 0. 0 being the starting value because actually there is no start. It doesn't start off with any cost. $3 for every one movie. So I'm going to go up $1, $2, $3. There's one movie. $1, $2, $3. There's a second movie. $1, $2, $3 for the next movie, and so on and so on. Now I unfortunately cannot draw a nice, well, I can draw a red line, but oh, that's kind of thick. Yeah, forget that. Let's just draw plain old lines. All right. Next up, let's go blue, shall we? Y equals 2x plus 3. There's that $3 we start off with automatically. Now, let's go up $2 for each movie. So up $1, $2, $1, $2 for the next movie, $1, $2 for the next movie, $1, $2 for the next movie, and so on and so on. Boy, I wish I had a blue line. That's all right. You'll get over it, Mr. Callan. Starting off at $3, going up $2 a movie. And so, ladies and gents, let's find that point of intersection. Maybe you realized I'm going to use purple for this. Where does the blue meet the red? Well, that would be, you guessed it, right here. And so what would the ordered pair of that point be? So I'm going to go down here and I'm going to notice the x coordinate would be 3. That means 3 movies. And the y coordinate appears we go up 9. So what does that mean? Well, if we were to check both equations, y equals 3 times some number x, y equals 2x plus 3, if we were to substitute in the coordinates, so anywhere you see an x, substitute in 3. Anywhere you see a y, substitute in 9. Now check this out. 9 equals 3 times the, yep, that's definitely a true statement. 2 times 3 is 6. 6 plus 3 is 9. 9 equals 9. Another true statement. See, it works for both. There's a lot of points out there that work for one. There's a lot of points out there that work for the other. Shucks, there's even more points out there that work for neither, but there's only one point in this case that works for both, and that would be the 0.39. Little studying up here of analyzing what this means. I'm going to ask you to pause, answer the following questions, and come on back when you're ready. So, which website would you rather choose if you only wanted 2 movies? Let's go with a nice crayon here. 2 movies. So let's find 2 movies and let's go on up. Okay, so the blue line is going to be $6, but the black line is going to be $7. Therefore, I would much rather choose movies you like. Onward. How about 3 movies? Well, here's 3 movies. Let's go on up that. Oh, wait a second. They're both the same. Right, the same price, right? Either. However you want to answer that. Onward, what about 5 movies? Here's 5 movies. Just go on up. Let's see, that one right there is going to be $13. Meanwhile, that one right there is going to be $15. So yeah, we would rather have G8 movies for 5. But I really want to emphasize question B. The point here means, because it's shared by both lines, it means that either one is equally acceptable. They're both good. All right, ladies and gents, let's go ahead and get ourselves started here. And I wonder if this would annoy you, because I can actually change my line colors. It's a little smaller, I apologize, but it's not bad. So let's go ahead and do this first one in red. It does not have a y-intercept. Excuse me, Mr. Callan, does have a y-intercept. It's just 0. So we're going to go ahead and put that 0.0 right there. Now we have a slope of 3 to 1. So let's go up 3 and right 1, and there's our next point. Let's go up 3 and right 1 again, and there's our next point. And we go on and on and on. As a matter of fact, we could go down 3 and left 1 actually since a negative divided by negative is a positive. And let's go ahead now and create a beautiful red line going through the following points. Boom. All right, first equation is graphed. Onward. Y-intercept, positive 4. Up 1, up 2, up 3, and up 4. All right. Now, no, that's too big. Oh well. Negative 1 is the slope. Let's make it negative 1 to 1, shall we? And therefore, we're going to go down 1 and right 1, and down 1 and right 1, and down 1 and right 1, and so on. Or we could always go up 1 and left 1, after all. Opposite of a positive, still a negative. And we'll draw ourselves a nice little line. And of course, what we're looking for is where will the blue meet the red? Where will that purple happen? Which you can probably already see it. So if we were to identify the x and y coordinates for that point, it appears, that x would be positive 1 and y would be positive 3. And if you don't believe me, you're always welcome to check. Go back up here, substitute in 1 anywhere you see an x, substitute 3 anywhere you see a y, and as you can imagine, both of those statements would be true. There's a lot of blue points, there's a lot of red points, there are even more points that are neither blue nor red, but there's only one point that will get you the solution to both of those equations, and that is when x is 1 and y equals 3. Now, I do want to point out that you are welcome to write your answer like such, but why not just write it as an ordered pair, huh? Go back if you need to. Let's do it again, shall we? Starting value, positive 1, slope 2 to 1. Positive 1 being the y-intercept, place that point right there. Up 2 and right 1, a rise of 2 and a run of 1, a rise of 2 and a run of 1, and so on. If you're still struggling with that, look up on the internet or look at my old videos, but I don't care how you learn as long as you're learning. Look up graph linear equation. I'm going to go down 2 and left 1 because, hey, let's be honest, the more points, the better we are, and the more likely we will be to find the intersecting point. Draw a lovely blue line and continue onward. Y equals 1/2 plus 4. Positive 4 being the y-intercept. Slope is 1 to 2. So positive 4, if x equals 0, y equals 4, will be straight on the y-axis. Now we got a positive 1 to 2, so we can rise up 1 and run to the right 2, a rise of positive 1 and a run to the right 2, up 1, right 2, and so on. We can also go down 1 and left 2 because, of course, the opposite of a negative, still a positive. Go ahead and graph the line right through that. Make this feller blue. And whereth lieth the purpleth? We can see that one point right in there. So what would the x and the y value be? Well, it appears that the x would go to the right 2, and the y value would go up 1, 2, 3, 4, and 5. Whoopsie. How about that? And as we did before, let's just do a little fun, huh? Let's go ahead and substitute in 2. 2 times 2 is 4, plus 1 is 5. That's a true statement. How about this one? Half of 2 is 1. 1 plus 4 is 5. Yep, we can check it. You can turn in a quiz or a test knowing that you have the correct answer. And let's wrap it up with one more, shall we? First equation, y is negative 2x minus 6. Okay, this is interesting. Not only do we have a negative y-intercept, but we also have a negative slope. So the y-intercept of negative 6 when x is 0, y is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Slope is negative 2 to 1. We go down 2 and right 1, down 2 and right 1. We can also go up 2 and left 1 and still have the opposite of a positive. Yep, that's a negative slope. So up 2 and left 1, up 2 and left 1, and so on and so on. Going all the way here. Let's go ahead and grab a line, grab your straight edge, ruler, whatever you got. And I don't care what color you use, ladies and gents. I just choose to use red and blue because I like to see that purple. Now, for the second equation, y equals 1/2 x minus 1, or should I say 1 to 2, which tells us the rise and the run. And when x is 0, y is negative 1. That negative 1 is telling us the y-intercept. So let's go ahead and plot that point at 0, negative 1. Slope of positive 1 to 2, up 1 and right 2, up 1 and right 2. You can probably already tell we're not going to be heading this direction. But if we go down 1 and left 2, down 1 and left 2, and so on, we can then graph a line going through the following points. And we can identify, okay, where is that pesky point? There she is when x is negative 2 to the left and y is, oh, that's interesting. It almost never happens when the x and y coordinate are the same, but hey, it can happen. And so if you wanted to check it, go ahead and toss it in. I'll do so with negative 2, negative 2. Negative 2 times negative 2 is positive 4. 4 go down 6 is negative 2. What's half of negative 2? That'd be negative 1. Go down 1, you're at negative 2. Works for both. I almost wish I would have made a mistake and shown you guys what it looks like when it doesn't work out. Alas, I did not think about that. So that's what I got for you, ladies and gents. The assignment for tonight. There is much of the assignment that you're going to do right here. Make sure you write your directions. Make sure to write the problem, unless the problem is a big old graph. But as you get to numbers 15, 16, 17, 18, 19, and 20, you will need graph paper, and so I will allow you to use some graph paper in class, or for you folks at home, you'll have that document in Kami coming up. All right, folks, that's what I got. Take care, do well, and let's grow.